You're watching the 5.3 Factoring Trinomials Day 1 notes. And I have to tell you that out of many math topics, I would say factoring trinomials is one of my most favorite things that I like to do in math. I know that that sounds really nerdy, but it's true, and you'll probably understand why in just a few minutes. Okay, will I convert you to be a trinomial lover? All right, number one. Let's take a trip down memory lane and let's multiply these two binomials together. If you're thinking that we need to set up the box method, you, my friends, are correct. So let's set up the box. We're going to multiply x plus 4 all times x minus 2. Okay, so 4 multiplication questions. X times x is x squared. We're going to get a minus 2x plus 4x, and a negative 2 times a positive 4 is a negative 8. Here are my like terms, and I end up getting 2x. So if I multiply these out, I end up with this trinomial x squared plus 2x minus 8. Okay, there's a reason why we did this, because in this lesson, okay, following me, I am going to give you this, and you are going to have to find that. So we're going backwards. And some of you might be like, well, how in the world are we going to do that? Well, let's figure it out. All right, question number 2 graphs the polynomial on a graph, and it makes this cute little parabola. Did you guys see it? X squared plus 2x minus 8. So we graphed it right over here. And it's saying, what are the roots? Oh, the roots. Those are like the x-intercept, x values. Okay, so we have an x-intercept here and there. So the roots are at x equals negative 4 and x equals 2. Okay. I don't know why we just did that, but let's go on to part B. It says factor the trinomial using the box method. Okay, so wait a minute. This is interesting. Okay, let's see what we have here. So in the past, we've put stuff on the sides and then filled in the box. But here, don't we have the guts and then we have to fill out the sides? So I'm going to take a minute and I'm going to put the x squared in here, right? Isn't that usually where the x squared belongs? And the minus 8, you guys are like, oh, that belongs down here. But then there's only 1, 2x. So let's think about where that came from up here in this example. Wasn't that my little tail? All right, so my tail is 2x. So what we want to try to find out now is what makes this box completed by filling out the sides. So how are we going to get x squared? What times what is x squared? If you're thinking x times x, you're a genius. Good job. All right, now we want to find two numbers that multiply to negative 8. Isn't that negative 8 and positive 1? Yay, we're done. So let's just make a quick little checkaroo with these two boxes here. We have to make sure that these two add to the 2x, and I get 1x minus 8x. Oh no. Well, that's not right. X, that's a 1x and a minus 8x. It's a negative 7x. That's not a 2x, so we're sad. All right, so I got really excited and just found out that I was wrong. So what we want to do now is try to figure out these two numbers so that they multiply to negative 8 but add to 2x. What two numbers could those be? If you're thinking 4 and negative 2, I think you're a winner, because negative 2 times 4 is negative 8, and then we have a negative 2x and a positive 4x adding to 2x. Wow, we are so amazing and happy. So my final answer, we're going to take this side and write it as a binomial times a binomial. So x plus 4 all times x minus 2 is equivalent to this binomial here. And then part C is asking us to make a connection. What do you notice about the roots compared to the factors? Well, let's check it out. The roots were at -4 and +2. Did you see this? It's a +4 and -2. So they're almost identical, except their signs are different. So the same number, but different signs. That's so cool. I wonder why it did that. Okay. Now, down at the bottom, quick little tip. When we're factoring, we're just doing the opposite of double distributing. And then when we factor, we're just rewriting the polynomial. So if you ever want to check your work, you can graph the original and the factored form, and the two parabolas will lay right on top of one another. All right, let's go on to question number 3. All right, we got a factor. So the first thing, you got it, set up that box. Okay, and then we're going to fill it in. X squared minus 11x, and then plus 24, positive 24. All right, so we got to find two numbers that multiply, or two terms that multiply to x squared. If you said x times x, you are right. And then what we need to do is find two numbers that multiply to positive 24, but add to negative 11. So numbers that multiply to 24 are 1 and 24, 2 and 12, 3 and 8, 6 and 4, 4 and 6. I guess I should have written it like that. So to any of those two numbers, will they ever add to negative 11? Huh. I think 3 and 8 do, but they both have to be negative. But will that work? A negative 3 times a negative 8. Well, that's a negative 3x. That's a negative 8x. Negative 3 times negative 8 is positive 24, okay. And negative 3 and a negative 8 is negative 11. So we found our answer. Our answer is x minus 8 all times x minus 3. Okay, let's head over to our calculator, do a quick check. So we are going to start a new document and we are going to graph them. I know it seems weird, but we're going to graph x squared minus 11x plus 24. And then hit tab, right? F of 1 is still here, but in this tab of F of 2, we're going to type in x minus 8, our answer, all times x minus 3. And if we did it correctly, the two parabolas will line up and, oh, did you see the magic? That was so amazing. Okay, let's take a look at example number 4. Example number 4, let's factor. All right, let's set up this box. Okay, my box looked a little sad. And let's plop our numbers in. X squared plus 22 always goes in the bottom corner, and my tail is 13x. So we got to find two terms that multiply to x squared. That's easy, x times x. And I want two numbers that multiply to 22 and add to 13. 2 and 11. Yes, so this is 11x. This is 2x. 11x plus 2x is 13x. I'm going to skip the check on this one for time purposes. But what we do want to do is we need to write our answer, don't we? So this is x plus 2, grabbing these binomials from my sides, all times x plus 11. And guys, sometimes people want to list them on top of each other, like put the x minus 11 down here. That's gross. Don't do that. We want to show that the two binomials multiplied by each other are the same as that trinomial. Now, number 5 is a cool one. It's a little different, right? Because it's missing something. But that's not going to stop me. So we have x squared minus 144, and there's no tail, so that's really just nothing, 0 x's. I'm liking this. All right, x times x is x squared. And we have to find two numbers that added together would be 0. And the only kinds of numbers that would ever add to be 0 is if they're the same number but different signs. So is there a number times itself that's 144? Yeah, it's 12. 12 times 12 is 144. But if I put a positive 12 and a positive 12 in there, I'm going to get 24x. Are you seeing what I'm seeing? One of them's got to be negative. So this becomes x plus 12 all times x minus 12. So fun. All right, last one. Here we go. X squared minus 14x plus 49. We got to factor it. Let's do this thing. X squared minus 14x plus 49. All right. X times x is x squared. Got to find two numbers that multiply to 49 but add to negative 14x. What do you think they are? Well, I know 7 times 7 is 49, but that's not going to get me a negative 14x. That gives me a positive 14x. So if you want me to make them both negative because it has to multiply to be a positive 49, you are correct. Because negative 7x plus negative 7x is negative 14x. So my final answer is x minus 7 all times x minus 7. Remember, we just take these two sides, write them in binomials next to each other. Some of you might want to get super fancy and say, isn't that the same as x minus 7 all squared? And you would be correct. Now, if we wanted to check our work, remember, all we would have to do is graph this and this or that on the same graph and make sure the graphs lined up. If you need help checking, I did the check for example number 3. So rewind and rewatch the video.